What is your computer doing right now? Processing 0s and 1s, billions of times per second, every calculation, every decision, every pixel. The same logic, either 0 or 1, either on or off, either yes or no. But what if I told you computers are coming that can be both 0 and 1 at the same time? Not just imagination, reality. And they're about to completely change your life. 2025 has been declared the International Year of Quantum Science and Technology by the United Nations. This isn't a coincidence, because as Bank of America analysts put it, this could be humanity's greatest breakthrough since the discovery of fire. So why such a bold claim? And how will this technology actually change our lives? This video chases those very questions. The limits of ordinary computers. The phone you're holding right now might seem miraculous, but it actually works with very simple logic. Billions of transistors inside constantly switch on and off. On 等于1, off 等于0. Even the most complex calculations are done with this binary system. The world's most powerful supercomputers use the same principle. Just faster, just more, but this approach has limits. Let me start with a problem I encountered last month. A friend of mine works at a pharmaceutical company. They're trying to develop a new cancer drug. They need to test thousands of molecular combinations. Our computer runs 24 hours, he said. But simulating all interactions of just one molecule takes months. What if you had a quantum computer? I asked. The same calculation would finish in 3 minutes, he said. Millions of lives could be saved. That's the problem. Classical computers try every possibility one by one. Quantum computers try all possibilities simultaneously. The quantum revolution. Everything at once. Quantum physics sounds complex, but the basic principle is surprisingly simple. In the normal world, objects stay in specific places. In the quantum world, a particle can be in multiple places simultaneously. This is called superposition. Think of it this way. A classical bit is either 0 or 1. A quantum bit, qubit, can be both 0 and 1 at the same time. 1 qubit equals 2 states simultaneously. 2 qubits equals 4 states simultaneously. 3 qubits equals 8 states simultaneously. 10 qubits equals 1024 states simultaneously. And do you know what Microsoft achieved recently? They connected 24 logical qubits together. That means processing 16 million states simultaneously. But this is just the beginning. IBM's goal, 100,000 qubits. Google's goal, 1 million qubits. When we reach these numbers, we'll be able to process more states simultaneously than there are atoms in the universe. Can you imagine that? Changes in daily life. Okay, impressive, you might say. But how does this affect me? Let me explain. Encryption and security. Internet security currently relies on the difficulty of factoring large numbers. Your credit card information, banking transactions, WhatsApp messages. All trust this mathematics. Today's most powerful computer would need millions of years to crack. Your internet banking password. A quantum computer? Minutes. Is this scary? Yes, but it's also exciting. Because quantum encryption is stronger. In a quantum internet, your messages are protected by the laws of physics. No one can eavesdrop, no one can crack them. Drug discovery and health. Let's return to my friend's story. Developing a new drug currently takes 10 to 15 years, costs billions of dollars, and 90% fail. Why? Because molecular interactions are so complex that classical computers can't simulate them. Quantum computers are different. Molecules already work at the quantum level. Quantum computers speak the language of molecules. Result? Cancer drugs could be developed in 10 months, not 10 years. Alzheimer's treatment could be found this century. Personalized medicine could reach everyone. Weather and climate. Why aren't weather forecasts reliable beyond 5 days? Because the number of variables in the atmosphere is astronomical. You know the butterfly effect. A butterfly flapping its wings in Brazil could cause a storm in Texas. Quantum computers can calculate all these variables simultaneously. They could predict weather a month in advance. Better model climate change. Better prepare for natural disasters. Artificial intelligence and machine learning. The supercomputers running ChatGPT consume millions of watts of electricity. Training takes months. Quantum-powered artificial intelligence? Like learning in parallel universes. A quantum AI can try all possibilities simultaneously. Learning time drops to minutes. Electricity consumption decreases by 99%. And most importantly, artificial intelligence that surpasses. Human intelligence could be born on quantum computers. The race between nations. Countries seeing this potential are making massive investments. Japan, $7.4 billion. America, $25 billion. China, amount classified but estimates suggest $50 billion. Europe, $8 billion. Spain, $900 million. Why such massive investments? Because the first country to achieve quantum supremacy will become the superpower of the digital age. Just like how countries that first possessed atomic bombs gained strategic superiority. That's why it's called the quantum race. And the race has already begun. Corporate breakthroughs. Not just governments, private companies are in this race too. IBM created the quantum network. Over 200 institutions are members. Harvard, MIT, Samsung, Merck. Their goal, a 100,000 qubit computer by 2033. Google claimed quantum supremacy in 2019. Their Sycamore processors performed calculations in 200 seconds that would take classical computers 10,000 years. Now their goal, millions of qubits. Microsoft is taking a different approach. Azure Quantum Cloud Platform. Everyone can access quantum computers. The 24 logical qubit achievement is just one step. Goal, general-purpose quantum computer. Chinese companies. Developments in China are somewhat mysterious. But what's known? The Jiuzheng quantum computer surpasses classical computers by trillions of times in specific calculations. Turkey's position. Turkey is also trying to participate in this race. TÜBİTAK launched a quantum technologies program. Koch University and Bilkent University are conducting research. But we're not yet in the international league. More investment is needed. Challenges and obstacles. Of course, like every revolutionary technology, quantum computers have problems too. Technical challenges. Quantum computers are very sensitive. The slightest vibration can disrupt calculations. They need to operate at temperatures close to absolute zero. 273摄氏度. That's why massive cooling systems are required. A quantum computer isn't the size of a refrigerator. It's the size of a room. Error rates. Current quantum computers are very error-prone. They make 1 to 10 errors per 1,000 operations. Classical computers make 1 error per billions of operations. To solve this problem, quantum error correction is being developed. But it's not perfect yet. Programming difficulty. Quantum programming is a completely different world. Classical programming logic doesn't work. New algorithms, new programming languages are needed. Languages like IBM Qiskit, Google Cirq, Microsoft Q-Hash are being developed. But very few people know them yet. Cost. A quantum computer currently costs millions of dollars. Maintenance costs are also very high. Only large companies and governments can afford them. But prices will drop, just like classical computers. In 1970, a computer cost millions. Now the phone in your pocket is more powerful. Economic and social impact. The quantum revolution isn't just a technical change. It's a societal transformation. Job market. New professions will emerge. Quantum engineer, quantum programmer, quantum security specialist, quantum algorithm designer. Old professions will change. Encryption experts will retrain. Data analysts will use quantum tools. Doctors will diagnose with quantum simulations. Education system. Mathematics and physics education will fundamentally change. Quantum mechanics will enter high school curricula. Programming classes will include quantum algorithms. Security and privacy. The biggest transformation will be in security. Current encryption systems will collapse. Quantum-safe encryption will become mandatory. Blockchain systems will change. Cryptocurrencies like Bitcoin will use new algorithms. Healthcare. Personalized medicine will become widespread. Genetic analyses will take minutes. Drug side effects will be calculated in advance. Diagnosis times will shorten. Treatment methods will improve. Healthcare costs will decrease. Ethical and philosophical questions. The quantum revolution raises not just technical questions, but ethical ones too. Power imbalance. Those who possess quantum computers will gain tremendous power. They'll be able to crack others' encryption. Monitor internet traffic. Manipulate financial systems. How will this power be controlled? Should quantum technology be democratized? The end of privacy when quantum computers collapse current encryption systems. All previously encrypted data will be exposed. Your emails, photos, messages, none will remain secret. This situation is called Y2Q years to quantum. The year quantum computers will start breaking encryption. Are we prepared? Human-machine relationship. What happens when quantum-powered AI surpasses human intelligence? Machines will be able to make better decisions than us, solve problems better, make better predictions. What will humanity's role be? Personal preparation. What can you do? Okay, a big revolution is coming, you might say. But what can I do? Education, first step. Develop quantum literacy. Watch quantum physics videos on YouTube. Join free courses from MIT, Stanford. Start learning quantum programming languages. Career planning, whatever sector you work in. Research quantum impact. Finance sector. Quantum algorithms will be used in portfolio optimization. Healthcare sector. Quantum simulations will be used in drug discovery. Logistics sector. Quantum optimization will be used in route planning. Investment. Follow quantum technology companies. IBM, Google, IonQ, Rigetti. Research quantum ETFs. But be careful, it's still early-stage security. Start using quantum-safe encryption tools. Apps like Signal and Wire are developing quantum resistance. Protect your most important data with quantum-safe methods. Future scenarios. The quantum revolution could develop in 3 different ways. Scenario 1. Gradual development. Quantum computers develop slowly. First used in specific areas, then become widespread. A 10 to 20-year process. Scenario 2. Sudden breakthrough. A major breakthrough suddenly occurs. Current encryption systems collapse overnight. Social chaos ensues, then a new order is established. Scenario 3. Fragmented development. Different countries develop at different speeds. Those with quantum supremacy dominate others. Digital colonialism begins. The technology gap deepens, whichever scenario occurs. Change is inevitable, hopes and fears. It's normal to feel different emotions about this revolution. Hopes, solving unsolvable problems. Treating diseases. New tools for fighting climate change. Accelerating scientific discoveries. Taking humanity to the next level. Fears. Collapse of existing systems. Job losses, security vulnerabilities. Power imbalances. Risk of losing control. Like every major technological revolution, the quantum revolution is two-sided. It depends on how it's used. Turkey's strategy. So where should Turkey stand in this race? Our strengths: strong tradition of mathematics and physics education, young and talented population, technology enthusiastic society, strategic geographical location. Our weaknesses: insufficient R&D investments, limited international cooperation, few quantum experts, low private sector investments. Recommendations: a Quantum Technologies Institute should be established. Quantum programs should be opened in universities. International partnerships should be developed. Private sector should be incentivized. A quantum startup ecosystem should be created. We must act before it's too late. Conclusion: on the threshold of a new age. The quantum revolution isn't just a technological change. It's one of the greatest transformations in human history. The discovery of fire, the beginning of agriculture, the Industrial Revolution, the Internet age, now the quantum age. This change won't be easy, but it's inevitable. Our choice: will we surf this wave or be crushed beneath it? As humanity, we've overcome every major change so far. We can overcome this one too, but we need to be prepared. The quantum world is coming. Are you ready? You're not alone on this journey. Millions of people are grappling with the same questions, experiencing the same excitement, carrying the same fears. But remember, every great breakthrough started with brave people. Those who stepped into the unknown. Those who embraced change. So what about you? Are you ready to be among the pioneers of this age? What kind of mark do you want to leave in the quantum future? What problems do you want to solve? What kind of world do you want to build? Share your thoughts in the comments, because this is a future we'll shape together. And remember, the quantum age isn't just the age of technology. It's also the age of imagination. Because in the quantum world, everything is possible. Being in multiple places simultaneously. Computing in parallel universes. Communicating faster than light. Science fiction is becoming reality. And you can be part of this reality.